Hi, I am Milot Mirdita, a PhD student at the Max Planck Institute for Biophysical Chemistry in Göttingen. My work focuses on building fast tools and databases for large-scale sequence analysis. Today, I'm happy to give you a quick overview to M6 taxonomy, a new workflow to assign robust taxonomic labels to contigs, metagenomic or otherwise. M6 taxonomy was developed inside the M6 homology search and clustering toolkit. First, I will explain the four major steps of our taxonomic assignment algorithm. We begin by extracting all possible fragments from each contig in 6 frames. This is done by scanning for stop codons, and after one is found, beginning a new fragment and extracting the next. The fragments are immediately translated to protein sequences. Since the previous procedure generates a huge number of protein fragments, we introduce a very fast, low sensitivity search step to check if a fragment is contained at all in the taxonomic reference database. We will speed up the later steps by rejecting a majority of fragments early. To assign a robust taxonomic label to each of the extracted fragments, we implemented a procedure we call Approximated to PLCA, which is an accelerated version of the often used to blast lowest common ancestor to PLCA assignment method. Here we use the MM6 pre-filtering algorithm to search against a reference database and note all candidate hits. We compute local alignments and find the best hit to the reference database and note the e-value. With the best hit aligned region, we align only against the previously found candidates and accept all sequences with a better e-value than the noted one. We compute the lowest common ancestor from the taxonomic labels of the accepted hit and assign this to the query fragment. In the last stage, we gather all assigned query labels for a contig and introduce a weighted voting procedure that gives the most specific taxonomic label that has a support of at least by default, 50% of query fragments. To show that this procedure performs well, we compare our method against CAT, a state-of-the-art taxonomy assignment tool that utilizes the prodigal gene predictor and Diamond for homology search. Here on the left, we see the result of a taxonomic binning benchmark using CAMBI's AMBER on the first CAMI Challenge high complexity bacterial dataset. AMBER reports very similar completeness and purity measures for both methods. However, MM6 is nearly 20 times faster. On the right, we see a benchmark where we simulated an eukaryotic metagenomic dataset by cutting assemblies of a SAR supergroup into fragments and assigning taxonomic labels to these with both methods. We see that MM6 is much faster while assigning taxonomic labels more accurately at all levels. M6 taxonomy fragment step does not rely on predicted bacterial genes and is suited for all domains of life. I hope M6 taxonomy will be useful for your research. You can find more details at mm6.com. I want to conclude with a big thanks to the other authors and the respective founders who enabled the development.